Part 2. This is for questions 7 to 10. Question 7. For the curve shown in the diagram, the normal to the curve at the point P with coordinates x, y meets the x-axis at n. The normal. You see, a normal is that line which is perpendicular to the tangent. So this is a tangent, then the normal is always perpendicular to that tangent. Are we there? Then they say that the point M is the foot of the perpendicular from P to x-axis. The curve is such that for all values of x in the interval 0 to pi over 2, the area of the triangle PMN is equal to tan x. But Roman 1 show that mn over y is equal to dy dx. Now, gradient of the normal, they have talked about the normal here. So all lines that are slanting like this, they have got a negative what? Gradient. And how do you get the gradient? You get the change in y. This is the change in y out of the change in what? In x. Not so. Now, point P has gotten these coordinates. So I can say this is x what? Y. Okay? That means this M here has gotten a certain x coordinate. They have the same x coordinate because this one is a vertical line. Are we there? And then we know that on x-axis, y is what? 0. So there is a 0 that we are having here. Now, we have our gradient. So let me begin from gradient of the normal. Gradient of the normal. That normal Pn. Gradient of the normal Pn is going to be equal to negative, okay? All lines that are coming like this, like I said, they have negative what? Gradient. So negative of this Pn. Pn, is it n or m? I think Pm, then out of this mn, which is the change in what? In x. Change in y over change in x. Are we there? So we shall get negative. What will be the change in y? So the change in y is going to be this y minus the 0. Y minus the 0. Then out of the change in x is mn. So I don't know the x coordinate of this n. I'm not going to say x, then also 0. No. These two do not have the same x coordinate. Okay? So I'm just going to leave this one as mn. Like that. Then gradient of the tangent, we know that it is the one that is equal to dy dx. Okay? So let me also write it here. The gradient of the tangent, is equal to now you know that these two are perpendicular. So the tangent here is going to be perpendicular to let me take this one off. I think it is not all that good. This one here. So I can say this is the tangent, then this is the normal. These two are perpendicular. Then, and you know that for perpendicular lines, m1, m2 is equal to negative what? 1. The product of their gradients is always equal to negative 1. So if this is the gradient of the normal, then gradient of the tangent is going to be negative 1 out of the gradient of the normal. Are we there? Gradient of the normal. So this one is going to be negative 1 out of gradient of the normal from here is negative y out of mn. Are we there? What does this one give us? And gradient of the tangent, you know that it is given by dy dx. Not so. Gradient of the tangent, which is known as dy dx, Again, that dy dx then will be equal to this. So this one, of course, this is a negative. We'll cancel with that negative. Then this one will somersault, will go up there. That means dy dx shall be equal to mn, then out of y. Isn't it exactly what is here? So that is that. Part 2, hence, meaning begin from where you have stopped, show that x and y satisfy this differential equation. Now, they talked about area of a triangle here, that the area of triangle PMN is equal to the tan x. And in here, I'm seeing the tan x. So area of triangle, PMN then shall be equal to tan of x. That is what we were given. But how do we find area of the triangle PMN right from here? Area of a right angle triangle is going to be a half, then times the base times the height, not so? So this one is going to be a half times the base, which is mn. Is it mn? Let's check again. Yes, mn, a half times mn, then times the height is pm, okay? The height is pm. In fact, let me put these bars to indicate that those are lengths. Then this one shall be equal to tan of x. Now, this is a half. Our mn right from here is going to be dy dx times y, not so? Mn is going to be equal to y times dy dx. So I will say this will be y times dy dx, then times what is pm. If you check here, pm is going to be this y minus the 0. So in other words, this length here is y. So I will multiply by the y here. Then this one will be equal to the tan of x. Now, this is a half. This is y times the y. Don't you get this y squared? And I think what we are looking for is already got. So a half y squared, then dy dx will be equal to the tan of x. And that is that. Part B, given that y is equal to 0 when x is equal to 1, solve this differential equation to find the equation of the curve expressing y in terms of x. Our differential equation is a half y squared dy dx, which is equal to the tan of x. When we are solving differential equations, we separate the variables. So we need to first separate the variables. So separating variables, and then after that we integrate, and integrating. So what shall we get? Of course, here we use cross multiplication. So we use multiplication and division in most cases. So when we cross multiply here, the 2dx will go and multiply with this. So that means this way we are remaining with y squared dy, which is equal to then 2 tan x, then dx. You see that? Then we can integrate both sides. When we integrate, this one will be y cubed out of 3. Then I don't need to put plus c, because this function is different from this one. So when I'm integrating them, I can put a constant this way, but even this way, I will put a constant. Now this constant, which is different from this one, when I get the difference, I will still get a constant. So in order not to waste time with that, you just put the constant on one side, and I prefer that you put the constant on the right side. So this is y cubed over 3 will be equal to, this will be 2. Then the integral tan, you know it is the same as sine out of the cosine. Okay? When you differentiate cosine, you get negative sine of x. Are we there? But then up here you are having sine x. So what do you do to this derivative of yours to get what you are having up here? We shall multiply it by -1, not so? Now this operation we have done on our derivative is going to be the coefficient, or that is going to be the one we are going to multiply with the natural log of the denominator. Does that make sense? So that therefore implies that we are having y cubed out of 3, which is going to be equal to 2, then times -1, then times the natural log of the denominator, like that. Then we shall put a c here. Now we can use these ones here. After integrating, and then we put this constant here, the arbitrary constant of integration, what we are getting here is what we call the general solution of the differential equation. Now, using the conditions given here, we can then find the value of c. After finding the value of c, then what we get is the particular solution. So we have x is equal to 0, and then y is equal to 1. So substituting here, we shall get a third, which is equal to -2, then natural log of the cosine of 0. Cosine of 0 is 1. Now, natural log of 1 will be a 0. So, meaning our c is going to be a third. So, the particular solution is therefore going to be y cubed over 3, which is going to be equal to -2, then the natural log of the cosine of x here, then plus a third. You see that? Then from there, we can multiply all through by 3 to eliminate this denominator that we are seeing. So that means here we have y cubed, which is going to be equal to -6, then the natural log of the cosine of x, and then plus a 1 here. You see that? Then after that, we can take the cube root, because they said that we express y in terms of x. So therefore, our y shall be equal to the cube root of, I can write the positive first, then the negative last. So 6, then the natural log of the cosine of x, like that. If you want, you can take this one up here, and then you say 1 minus the natural log of cosine power 6 of x, like that. So, but I'm going to just leave it. I'm going to just leave it like this here, and that is that. Question 8. I can see this one is coming from differentiation. The diagram shows the curve y is equal to natural log of x out of x to the power of 4, and its maximum point m. The fact that they have given us the nature of this point here, then this one is a stationary point, and then they want us to find the exact coordinates of m. So we need to differentiate and then equate to 0. But you know that for stationary points, then dy dx is equal to 0. Now this is a quotient, so we are going to use the quotient rule. And you know that when you differentiate with respect to x, u out of v, then we are going to have v du dx minus u, then dv dx out of v1 squared. So our dy dx here is going to be equal to, this is the v, this is the u. So v is x to the power of 4, then times the derivative of the natural log of x minus u, which is the natural log of x, then times the derivative of x to the power of 4. Then after that, you get this x to the power of 4, and you square it. But then we shall equate to 0. And then when you differentiate, you know that when you differentiate natural log of a function, then you get that function, you differentiate it, then you divide by that same function. You see? So here we are differentiating x, and then we are getting a 1. Then we divide by that same x. Then here we shall get this natural log of x, then we multiply with, when you differentiate x to the power of 4, you get 4, then x to the power of 3. You see that? Then this one is going to be equal to 0. When we cross multiply, this one will just multiply with that 0. Is that clear? Now, this is x to the power of 3, then minus. I can write this one first so that we don't interfere with this. So you can have 4, then x to the power of 3, then natural log of x, which is equal to 0. So x power 3 is common. That means I can have 1 minus 4, then natural log of x, which is equal to 0. So meaning your x power 3 can be equal to 0, and then your x becomes a 0. Okay? Then, but then right from here, when x is a 0, that is on the y-axis, but you can see that we are not getting any other turning point. Why? Because if x is 0, this one cannot cut the y-axis because we don't have natural log of a 0. On y-axis, x is 0, so natural log of a 0 is not there. That's why this one, this graph will be meeting this y-axis at infinity. So y-axis is an asymptote. Okay, so we are not taking this value here. We are not taking this, and even on the sketch here, you cannot call this one the x coordinate as a 0. You see that? That means the value of x is going to be got from this factor here, 1 minus 4, then natural log of x is equal to 0. So we have 1, which is equal to 4, natural log of x, then bring the 4 here. You will get 1 out of 4, which is equal to the natural log of x. And then from here, we shall get x, which is equal to e to the power of a quarter. Not so. Because this one is log base e, then the x, which is equal to this a quarter. And we have a rule in logarithms that if you have log base a, the power of b, which is equal to c, then a power c is equal to b. A power c is equal to what? To b. That is why I'm saying e to the power of this, then is equal to x. You see that? All right. Then from there, we can proceed to get the value of y. Now y shall be equal to, you come back here, this is natural log of x, but natural log of x we have seen here, it is a quarter. So we shall say that that is a quarter, then we divide by x to the power of 4. So our x is this one here, so will be powered by what? 4. So using rules of indices, these two will multiply, then you will get a 1. So that means y will be equal to 1 out of 4e. Not so? So therefore, the coordinates of m are going to be, the x coordinate is e to the power of a quarter, and then the y coordinate is 1 out of 4 of e. And that is that. We don't need your decimals because they said exact. So you leave the e's there like that. Part B, by using integration by parts, show that for all values of a greater than 1, then the integral from 1 to a, natural log of x out of x power 4 with respect to x will be less than 1 over 9. Now, using integration by parts, we should have what we call a product of two functions. Okay, so here we are having the integral from 1 to a. I can take this one up such that it is x to the power of negative 4, such that you can easily see that these two, what we are having here is a product of the two functions. So in integration by parts, one of the functions is supposed to be differentiated, then the other one integrated. So how do you know which function to differentiate and which one to integrate? You use this acronym ILATE. ILATE, I here stands for inverse trigonometric functions, L logarithmic functions, and we can see a logarithmic function here, then algebraic function, then T is trigonometric function, Trigonometric functions are treated differently from the inverse trigonometric functions. And then this is exponential functions. So based on what we are having here, this is algebraic. This is the one here, and then logarithmic. Now, a letter that comes before the other, that is the function we are going to differentiate. So for this case, we are going to have, what are we going to have? This one here. Logarithmic is the one that we are going to differentiate. So u shall be equal to the natural log of x. So you differentiate it, you will get 1 out of x, and then dv dx. That is what we are going to integrate. We have x to the power of -4, so v will be the integral. Now we increase the power by 1, that is that, then we divide by the new power. Are we there? All right, let's proceed. So this one will be equal to the integral. I mean, for integration by parts, you have something like this. When you integrate, in fact, let me put this one a bit down. So when we are integrating u, then dv dx with respect to x, we get uv minus the integral of v, then du dx. So this is u, but when we look at what we are having here, it is du dx. So we are supposed to differentiate it, you see? Then this is dv dx, but then when we look here, we are having v. How do you get v from dv dx? That is when you integrate. So that's why I'm saying that one function has to be differentiated. That is the one you equate to u. Then the other has to be integrated. That is the one you equate to dv dx. Is that clear? Okay, now what is our u? Our u is this one here. Our v is this one here. So this one is actually the same as saying negative 1 out of 3, then x power 3 in the denominator. Like when you use indices, this one can go down, right? So we shall have uv. Our u is natural log of x, then times the v, which is negative 1 over 3x cubed. Okay, then from there minus the integral. Our v is going to be negative 1 over 3, then x word cubed, then times du dx, which is 1 over x here, 1 over x. Then with respect to x, I can actually put the limits here. Then I put a and then 1. Then what else are we getting here? So here it is better you write this first and then the natural log afterwards, because some people can get this x here and then they multiply with this, and that is very, very wrong. So I can put this one just here, then I say natural log of x, and then minus and a minus, that one becomes a plus, not so? Then the integral, I can take this 3 outside, so we can get a third, then the integral of what do we have here? X power 3 times that x there, we have 1 over x power 4, but that is the same as writing x to the power of negative what? 4, then with respect to x. But if you can observe very well, what we are having here is exactly here, so it gives us this. Now that means we are going to have negative natural log of x out of 3, x to the power of 3, then plus, this is a third, then times negative 1 over 3, then x cubed, because this one is this, okay? Then you have a and then 1 here. Now let us put the limits. Where there is x, now put an a, so we shall have 3, then a cubed here, then minus, this will be 1 over 9, then a cubed. Then after that, we subtract, you put a 1. So you'll get a 0 here because natural log of 1 is a 0, okay? So 0, then put 1 here. We shall get negative 1 over 9. This 3 will multiply with this. Okay, then we continue, we simplify this. We are going to have negative 1 over a out of 3a cubed, then minus 1 over 9a cubed, then plus 1 over 9, because this negative affects that negative. Okay? Now I simplify this. I get it as one fraction because right from here, okay, they say this one is less than. For all values of a that are greater than 1, then this one has to be less than 1 over 9. Okay. Now I think this one is already out. So if I put 1 over 9 here, it is positive. Now these ones are negatives. So we shall have minus. Then I can write this one like this here. Natural log of a out of 3a cubed, then plus 1 over 9, then a what? Cubed. Now, for all values of a that I'm going to put here, of course, not putting what? Not putting negatives in here or 0. But here they even told us this one here, a greater than 1. Now, I can conclude and say that for a greater than 0, okay, what I'm going to substitute here, you can see that we are having 1 over 9, then minus something. So whatever you are going to subtract from here, it's a positive thing, okay? And it is going to be smaller than this one here. So you are going to get something smaller than this. 1 over 9 minus something from it, you are going to get a smaller value. You see that? So for a greater than 0, 1 out of 9 minus natural log of a out of 3a cubed, then plus 1 out of 9a cubed. This one will always be less than 1 over 9. So therefore, the integral of what? The integral from 1 to a, our natural log of x here out of x power 4 dx has to be less than 1 over 9. And that is that. Question 9 is coming from vectors. The quadrilateral ABCD is a trapezium with AB and DC parallel. With respect to the origin O, the position vectors of A, B, and C are given here. Then part A, given that DC is equal to 3 times AB, find the position vector of D. Now, I'm going to do a small sketch here for this trapezium. Maybe it is like that, and then like that. Not necessarily the isosceles trapezium. So these two are parallel sides, okay? So I can have D here and then C, because they say DC is 3 times AB. So I can have A to B, and also master the direction when it comes to vectors. This is A to B, this is D to C, just as what we are given here. You see that? So it can be A, B, C, D. Then they're saying find the position vector of D. Right from here, we can have this. So we need to find AB and then DC. So if DC is 3 times AB, how do we get AB? You don't waste time. Get the last minus the first. I've already said this in vectors. If I have, maybe this is the origin here. So I have this and that. So for me to get AB, I will say AO, then plus OB. But you see that the AO is in the opposite direction of OA. So this one will be negative of OA, then plus this OB here. Now, the negative here. So we write the positive first. So OB, then minus the OA. Is that clear? So when you are using the position vectors, you don't need to waste time. You just say the last minus the first. Okay, now let us substitute. We have our OB. Right from here is 1, 3, 1. So 1, 3, 1. Then our OA is negative 1, 2, 3. Negative 1, 2, 3. So this one will be 1 minus 1 minus 1. And that will be a 2. Then 3 minus 2, that will be a 1. And then 1 minus 3, that's a negative 2. Okay. Then even here, our DC is going to be the last, which is OC, minus the first, which is OD. Are we there? Then this one will be equal to 3 of AB, which we have gotten here as 2, 1, negative 2. Now, we make OD the subject of the formula. So bring this one here, take this one this other side. So what is our OC? OC is given as this 2, 2, 2, 2, negative 3. Are we there? Then bring this one this way. 3 will multiply with whatever is in there. So we shall get 6, then 3, then negative 6. Then this one will be equal to the OD. So what is OD therefore? This one is going to be 2 minus 6. That is a negative 4. Then 2 minus 3. That is a negative 1. Negative 3 plus 6. That is a 3. Okay. Since these ones were given in terms of I, J's, and K's, then I will say OD will be equal to negative 4I, then minus J, and then plus 3K. As simple as that. Then part B, they are saying state a vector equation for the line through A and B. I've always used this illustration here that, okay, they are saying A to B. So suppose you are moving from your home. This is O. Then you connect to the road. Where you connect to the road, that is point A. Then as you go to wherever you are going, there is a point here, maybe you make a stopover, okay? But then there is any other point that lies on this line here. So let's say that is R. So to go to any point after this, this distance AR is a certain scalar you can multiply in AB. Are we there? So this one can be B, then this one can be A. Then you need to get OR, which is going to be OA, then plus AR. So OA, then plus AR. Are we there? But AR is lambda AB. I can express this AR in terms of what I know. So there is a scalar I will multiply in AB to get my distance AR. Are we there? All right. So that means the equation through the line A and B is going to be, in other words, AR and AB are parallel vectors. Parallel vectors are ones that can be expressed in terms of each other as scalar multiples of each other. These are vectors that can be expressed as scalar multiples of each other. So what is our OA? It was given as negative 1, 2, 3. So we have negative 1, 2, 3. Then this will be lambda. And then AB, we got it as 2. I think it is here. 2, 1, negative 2. So I'll write 2, 1, negative 2. And that will be the vector equation of the line through A and B. Or if you want, you can write it in terms of I, J, and K. So, or r can be equal to negative I, then plus 2j, then plus 3k. We always put these wavy lines on the I, j's, and k's. For us, we cannot write I, then we make it bold. Like you write it like that, then also j, you make it bold, it looks weird. So you put those wavy lines there. Plus, then we are having lambda, and then here we have 2I plus j, then minus 2k. So you choose the one you want, but me, I always prefer this. Part C, find the distance between the parallel sides of the trapezium, and hence find the area of the trapezium. Of course, that one will give us the height of the trapezium, okay? And if we are to find the height, I mean the area of the trapezium, then we shall need the height, not so. So let me actually take this one up here. Maybe we have that. I don't know how it is moving. I'm just giving an example here. So this is just a simple illustration. So this is A, this is B. It can even be rotated. Somebody can draw it like that, you know, doesn't matter. So this is D, this is C. We have this one and this. So we got our CD, and I mean AB, and then DC. Okay. Now, what do we have here? The distance between these two here. So I need to find the foot of the perpendicular. So I'm going to connect this one here, like this. Okay, the foot of that perpendicular there. Now, this foot of the perpendicular here is lying on this line through C and D. So what does this mean? I need to find the equation of the line through C and D. You see that? When I find the equation of the line through C and D, then I can get the coordinates of this F. Because if a point lies on the line, then its coordinates must satisfy the equation of that line. Are we there? So let us look at the direction vector of that CD. Of course, it is going to be that CD. But since these two are parallel, we can take the direction vector as the same. But let us have DC, which is equal to 3 of AB. So this is 3 times our AB is 2, 1, negative 2. That means we are going to get 6, 3, then negative 1, 6. And I think we also got it before. Now, that means, based on what we are having here, this BF here is perpendicular to this DC here. Okay? So, what are we going to do here? What will be the coordinates of F? Now, equation of line through C and D. So this one will be R, which is equal to, I can say OD, then plus mu. Then the directional vector can be the DC. So DC. Now, if you are going to use DC here, then what should be here would should be a D. Now here, I can also have OC, but then here I will have CD. So it is the first one to be mentioned here. You get that? Okay. Now, what do we have here? Our R is going to be OD. Remember, we got it as negative 4, then minus 1, then 3, then plus. This will be this. And then DC, we have it as 6, 3, negative, 6. By the way, you could even take AB, no problem. And then because we usually, for directional vectors, we take the simplest. So you can use this one here other than this. It also gives you the same value or the same stuff that we are looking for. Now, that means from here, we can get the parametric equation. So the x coordinate will be this, then plus 6 mu, and then minus 1 plus 3 mu, like that. So the coordinates of f are going to be, we are going to see, in fact, let me just write OF, the position vector of f being a point that lies on this line, then its coordinates must satisfy the equation of this. So we shall have negative 4 plus 6 mu, then negative 1 plus 3 mu, and then 3 minus 6 mu. So for whichever value of mu that you get, then you'll be locating the points that are on that line. So if mu is 0, then we are having this one here, which is D. Then if mu is 1, then you get another point like that, like that, like that. Okay. Now, we are going to have BF also. We need this one here, BF. So this BF here is perpendicular to this what? DC. So BF, you get the last, that is OF, minus the first, OB. You remember that? What is our OF? It is negative 4 plus 6 mu, and then negative 1 plus 3 mu, then 3 minus 6 mu. Then we subtract our OB. We were given OB when we check here, it is 131. So 131. So this one is now going to be negative 4, then minus this one, that will be a negative 5, then plus 6 mu. Then negative 1 minus 3, isn't that a negative 4? Then plus 3 mu. And then 3 minus 1, that would be a 2, not so? Then minus 6 mu. Like that. Now, vectors BF and DC are perpendicular. Therefore, their scalar product has to be equal to what? 0. So we do that. Now our BF is this one here. I'm just going to copy it, put it down here. Then we dot it with what is DC? It is here. So that is 6, 3, negative 6. Then this one is equal to 0. So this one will help us to find the value of lambda such that we can get the position vector of f, the foot of the perpendicular. So you multiply. Here we shall get negative 30 plus 36 mu. Then here we shall get negative 12, then plus 9 mu. Then here we get negative 12, then plus 36 mu. And this one will be equal to 0. 36 plus 36, that is 72, plus 9, isn't that 81? 81 mu. Then negative 12, that is minus 24, then minus 30, that will be minus 54. So that means mu shall be equal to 54 out of 81. By 9, we can get a 6. By 9, we can get a 9. By 3, 2. Then by 3, 3. So this is 2 out of 3. Then from there, our f here, remember they said, okay, let's find our OF. Do we need OF or BF? Because they want the distance. This is the one here. So let us substitute in what? In BF. So BF here is going to be -5, then plus 6 times 2/3, then -4 plus 3 times 2/3, and then 2 minus 6 times 2/3. Then our BF is going to be equal to, so here you'll get 12 divided by 3. What do you get? 4. So -5, and then plus 4, that's a -1. Then here, of course, the 3 goes, -4 plus 2, you get a -2 here. And then here we shall get -4. So 2 minus 4, that one will be what? -2. So we get a -2 here. Now, that distance between the two parallel sides, that would be the BF. Okay, the modulus of this is going to be the square root of -1 squared, then plus -2 squared, then plus -2 squared. Okay, and this one will be equal to 4 plus 4, 8, plus 1, 9. Root of 9 is 3. As simple as that. Then area of trapezium. So we need to get these lengths here, because remember, area of a trapezium is going to be a half h, then into a plus b. The a and the b, these are the two parallel sides we are talking about. So we are going to find the length of AB. Since DC is equal to 3 times AB, when we find the length of AB, then we just multiply by 3 to get this one here. Are we there? So length of AB shall be equal to the square root of, what is our AB? That is 2, 1, -2. 2, 1, -2. So this one will be 4, then plus 4, 8, plus 1, 9. So this one is also what? 3. Now, our DC, the length of DC is going to be 3 times 3, which is equal to what? 9. I said you just get this one here, the 3, then times what you get here. Because when I get the modulus here, this one will just pop out, then we get like that. Okay? So you just multiply by 3. You don't need to again get this one. You also find it's, no, that is wastage of time, which you don't have. So that means area of trapezium shall be equal to a half h into a plus b. So that will be a half. The h is this one we got. Then a can be this, then be this one here. So we have 3, then plus, then 9. Now this is 12 divided by 2. What do you get? 6 times 3. This one gives us 18 square units. So our answer becomes 18. And that is that. But verify that -1 plus root of 2i is a root of this equation. So we are seeing there is a square. So I'll get -1 plus root of 2 squared here. I will square the -1, that will be a 1. Then 2 times this times that will be -2 root 2 of I. And then I will square this, So we shall get 2, then I squared. But you know that I squared is negative what? 1. So that one should be known in complex numbers. So meaning that this one simplifies to negative 1, then minus 2 root of 2i. Now when I come to z power 4, this one here, root of 2i, then power 4. This is the same as saying negative 1 plus root of 2i, okay, squared, then times negative 1 plus root of 2i squared, not so? Or in other words, I can say this one here, then squared, but this one is here, so I will say negative 1 minus 2 root of 2i, and then after that I will square that. So square this negative 1, you get a 1, then 2 times this times that will be a positive, then 4 root of 2i, then square this one here, you will get a 4 times the 2, that will be 8. Then there will be I squared, but I squared, like we said, is negative 1. That means, remember here you are having a plus because you squared the negative. Now, the I squared is going to make this one a negative. So we are going to have minus 8 like that, and then it simplifies to 1 minus 8, that's a negative 7, then plus the 4 root of 2i, not so? Then now we substitute here. So we are going to have z power 4. This is okay, let me write this, negative 1 plus root of 2i here, squared, okay, it is power 4, then plus 3, then we have negative, what do we have here? Negative 1, then plus root of 2i squared, then plus 2 times negative 1 plus root of 2i, wherever there is z, I'm putting this, okay, then plus the 12. So this one gives us what? This one here is what we got here is here. So we put negative 7, then plus 4 root of 2i. Then here we are having a 3 multiplying with this one squared. We got it here. So we have negative 1, then minus 2 root of 2i, and then plus, then the 2 times negative 1 plus root of 2i, then plus the 12. Now we open those brackets. So negative 7, then plus 4 root of 2i, minus 3 minus 6 root of 2i, then minus 2 plus 2 root 2i, then plus 12. You see that? Now separate the real from the imaginary. So here I have negative 7, then there is negative 3, then there is negative 2, negative 2, then there is positive 12, positive 12. Then the imaginary part, we are having 4 root of 2, 4 root 2, then there is minus 6, minus 6 root of 2, then there is plus 2 root of 2, then I. You can see that this is negative 12, then plus 12, which will be 0. Then this is 4 plus 2, that will be 6, minus the 6, that will also be what? 0, I. So since we have substituted in here, a root is the value you're going to substitute in a function and you get a 0, okay? So therefore, this is a root of this equation. Are we there? The next part B, they are saying find the other roots of this equation. This is 7 marks. Now, if this one here is a quartic equation, we are expected to get 4 roots. But now, since we are having this one as a complex root, this one does not move alone. It moves with its complex conjugate. So, if this one is a root, then its conjugate is also a root. So I can say if, okay, -1 plus root of 2i is a root, okay, then its conjugate, its complex conjugate, which is -1 then minus root of 2i, you just change the sign of the imaginary part, is also a root. Okay, now another thing you also need to know is this one here, that the 2 roots are going to give you a quadratic factor. Okay, that means this one here is z power 4. So we are having 2 quadratic expressions, z squared, there is z squared here. Okay, so this first one here is coming from this and its conjugate. Now we need to find this. So I can find the quadratic expression that is coming from these 2 complex roots. Then after we divide all through, we use long division or expansions. Okay, you use what is convenient for you. I can show you both of them. Now we can say we find, so finding the quadratic factor, or the quadratic equation. I can say that the quadratic factor that is formed from -1 plus root 2i and -1 minus root 2i. Okay, now you should know this one here. If I have 2 roots, let's say x is equal to a and then x is equal to b. Now solving backwards, I can have, you have always seen that when we are solving quadratic equations, after getting the values, I tell you that bring back this one here to give us the factors from which the roots come. So bring this one here, you will also get x minus b, which is equal to 0. So when you are solving using factorization, it is from here that you equate these to 0, and then you get these values, not so? Now, suppose I open the brackets here. X times the x, you will get x squared. Then this times this, you get minus b of x. Are we there? Then this and this, you will get minus ax. And then this and this, you'll get a plus ab, which is equal to what? 0. Now, negative x is common here, so I'll pull it outside. Then I will have a plus b in here. So I will do it like that. Now, you can see here that this is a product of roots, these 2 roots that I'm having. And then this one is the sum of the 2 roots. So long as you have the sum of the 2 roots and the product of those 2 roots, then you can form a quadratic equation, that can come from those 2. You see that? So I will say that we are going to use, you can say the quadratic equation from those 2 roots is going to be z squared minus the sum of roots, are we there? Of z, then plus the product of roots. Then this one will give us a what? A 0. So we shall have z squared minus the sum of the roots, these 2 added together. So you get -1 plus root of 2i, then plus -1 minus root of 2i, like that. Then z, then plus the product, you have -1 plus root of 2i, and then negative 1 minus root of 2i. Okay, so here we can easily see that the imaginary part is going to go. So we have negative 1 minus 1, that will be negative 2, not so? So minus, then we get negative 2 here, then z, then plus the product. This is a difference of two squares, so I will just say negative 1, then squared, minus the root of 2i. You also square that. Are we there? So here we shall get a 1, then minus 2i squared. Are we there? But I squared is negative 1, so that means we shall have 1 then plus the 2, which is a 3. So the quadratic equation from here is z squared, then in fact, okay, let me take this one away, and then I say equation, quadratic equation, that is formed from this. Okay, so z squared, negative and a negative, that one will become now a positive. So 2z then plus 3, which is equal to what? 0. Are we there? Now we can either use long division or expansion. Okay, you can use whatever you want. Now we are going to divide our polynomial, which is z power 4. Now there is no z cubed, so I will put 0, then z cubed, then we have 3, the equation which we were given, okay, 3z squared, then plus 2z, and then plus the 12. Now what we have gotten here is the one we are going to divide in here. So it is going to be our divisor. So you divide the first with the first, then the rest you multiply. So z power 4 divided by z squared, you get z squared. So I'll write the z squared up here. Now the rest I'm going to multiply with this. So z squared times this, you are again going to get z power 4. Then 2z times this, you are going to get 2z squared. No, z cubed. Pardon me here. Then 3 times this, you will get 3z squared. Now when we subtract, you see that here we are having, of course, the first one here disappears. Now a 0 here minus a 2. So you are getting negative 2z cubed. Then this z squared disappears. Then I can drop these ones here. So plus 2z, then plus 12. Now divide the first with the first here. So negative 2z cubed divided by z squared. Then we shall get negative 2z. Then the rest we multiply. So z squared times negative 2z, that is negative 2z cubed. And then 2z times negative 2z, that will be a minus 4z what? Squared. Are we there? Then 3 times 2z, we shall get, that is minus 6 of z. Then we can subtract. When we subtract here, of course, the first one disappears. Then there is a 0 here for z squared. Then minus 4. So that will be positive 4z squared. Are we there? Then 2 minus 6. That one will be a positive 8. You following? Then next, we shall have the 12 dropping. Now we proceed. We are going to have 4z squared divided by z squared. That will be a 4. Then z times the 4. Here you get, z squared times the 4. That is 4z squared. 2z times the 4. That will be 8z. And then 3 times the 4. Then you get the 12. So when we subtract, then this one disappears. Okay. Now, that means our z power 4, then plus 3z squared plus 2z, then plus the 12, which is equal to 0, is now going to be this one here. Okay. Then times what we have gotten up here, like this. So I'll just say this quadratic factor times this quadratic factor will be equal to what? To 0. Are we there? Now, since this one, we know that it gave us the other two complex conjugates, we just solve this one here. So z squared minus 2z plus 4, which is equal to 0. Then our z here is going to be minus b, then plus or minus to the root of b squared minus 4ac, then out of 2a. So this one will be a 2, then plus or minus. This one will be a 4, then plus 16, that is 20. So you have root of 20 out of, no, this is not correct. Pardon me here. So this is 4, then minus the 16. Okay, you are getting negative 12. So we are getting negative 12. Now, out of the 2. So root of negative 12 is the same as saying root of, let's say 4 times root of 3 times root of negative 1. So root of 4 is a 2. Then root of 3 remains. And then root of negative 1 is I. So I'll have 2, then plus or minus 2 root of 3, I. Then out of what? 2. Now that 2, of course, is going to reduce these ones here. And then we shall have 1, then plus or minus root of 3, I. So I conclude, and then I say other roots. Other roots are, you remember the other complex conjugate, negative 1? When we solve this one here, it gives us the two complex numbers. The first one we were given was negative 1, then plus root of 2i. But now we are going to get its complex conjugate, which is this. Then the next ones are here. So we are having 1, then plus root of 3i. And then the other one will be 1 minus root of 3i. And that is that.